In activity 3.2, we're going to be exploring mineral hardness. How do scientists specify the hardness of a mineral based on their properties? Minerals being the building blocks of rocks, they form on many different conditions and have a lot of different properties that we use for identification purposes. Of those include mineral hardness, color, clarity, streak, crystal form, cleavage, fracture, tenacity, and specific gravity. It's through the use of these common items on Mohs hardness scale that we're going to be able to use and identify the hardness of a mineral to identify the mineral. Those items include a porcelain streak plate, a glass plate, a paper clip, which can be representative of an iron nail, a copper penny, and our fingernails. And we will also need our mineral kit. All right, once we have all these materials, we're going to have the students go through and predict the hardness of one of our samples. For your lab manual, it gives you sample 9A in our mineral kits to begin with. So I'd have the students open up their kits and pull out sample 9A. They also already have with them their Mohs relative hardness scale, which lists the items that we just went through, which are the porcelain plate, the glass plate, the iron nail or the paper clip, the penny, and our fingernail, and list them from increasing hardness from the bottom to the top, with the porcelain plate being the hardest and your fingernail then being the softest. So their job is going to be to predict what the hardness is based on those common objects of the sample that they have as it relates to these items that are listed over here: talc, gypsum, calcite, fluorite, apatite, orthoclast feldspar, quartz, topaz, corundum, and diamonds. Along those lines, we always want to start with our break point, which is going to be glass. Glass is what is going to determine the relative hardness of that item being a hard mineral versus a soft mineral, in which marks us at about a 5.5 on Mohs hardness scale. One of the things the students need to remember is as they are testing the hardness, is we always want to remember that harder objects always scratch softer objects. You never want to hold the glass in your hand when you're scratching your object or your mineral against the glass. In case it breaks, you cut your hand. Same thing with the porcelain plate. We don't want to hold that in our hand when we're streaking or we're testing that item. So leave those on the desk, take your mineral and rub it across there, and we're going to work our way from glass either up the scale or down the scale. So the first test we have to do is take our mineral, scratch against glass, and see if it leaves a scratch. And Lauren, did your mineral scratch the glass? No. It did not. So is that mineral going to be harder or softer than the glass?
Softer.
It has to be softer. So we're going to work our way down to the next item. So on your list of Mohs hardness common objects, what would be our next item?
The paper clip.
It would be our paper clip. So we're going to go ahead and open that paper clip up. So we have one pointing in. Now we can hold the mineral in our hand and we can see if our paper clip then scratches that mineral. So what do you think, Isaac? Did it scratch the mineral?
It did.
It did for sure. Okay, so is that paper clip harder or softer than the mineral?
Harder.
The paper clip has to be harder. So do we have to go up or go down Mohs hardness scale?
We have to go down.
We have to continue down. So the next item on our list then, Lauren, is the
penny.
The copper penny. So we're going to do the same thing with the copper penny. We're going to rub it against the mineral and see if it scratches that mineral. And Lauren, did it scratch it?
Yes.
Yes, the penny did scratch it. So that means that my penny is still harder than that mineral. So we're going to continue to work our way down. The next item on our list there is going to be our fingernail. So go ahead and take your fingernail and see if you can scratch that mineral with your fingernail. Isaac?
No.
Does not. So that means that my fingernail is softer than the mineral, but the mineral is softer than a copper penny. So based on Mohs hardness scale, where would that fall if it's between the copper penny and the fingernail?
A 3.
It would be a 3, what mineral falls as a 3 on Mohs hardness scale?
Calcite.
It's calcite. So that mineral you identified has a hardness value of 3, and it is going to be the mineral calcite. Now, within their lab manuals, you then have the remaining 8 minerals on Mohs hardness scale, which includes corundum, topaz, quartz, orthoclast feldspar, apatite, fluorite, gypsum, and talc, to go through and identify those unknowns based on their hardness values using the common items that are given to us on Mohs hardness scale. So if we run into a problem here, if you notice on your hardness scale, what happens after you get past the streak plate, that 6.5? When we go to the 7s, the 8s, the 9s, and the 10s, is there anything we can rub them against?
Each other.
Oh, you could rub the minerals against each other. What would that tell us about the hardness?
You could compare them to each other, like whether or not they're harder than each other, and it would tell you which one was at the top and which one was softer.
Very good. Yes, we could just rub them against each other to determine their hardness relative to one another, since we don't have any items that go beyond that 7, 8, 9, and 10 mark. The same thing with gypsum and talc at the bottom are 1s and 2s. We can just rub those items against each other. If you really want to take an easy route, you can let the students just look up a picture of what those would look like on the internet to try and narrow those down even more to get that sample correct. What is it that we use to determine the hardness of these minerals based on these common items? What's our break point between hard and soft?
Glass.
Yes, the glass is going to be our starting point. If it scratches the glass, we have a hard mineral. If it doesn't scratch the glass, that mineral would be identified as being a soft type mineral. And then what is it about a mineral that ultimately would determine whether that mineral is a hard or soft mineral itself?
The chemical composition of the mineral.
Good, yes. The chemical structure of that mineral as it was forming determines whether it's going to be a hard mineral versus a soft mineral.